Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. As you know, I am engaged in a brass cannon project that was a bucket list item for me. And in researching visually what I want to end up with, I ran across the guy on the internet. I got to give him a shout out because every once in a while you just find a scale model or craftsmanship and it just blows you away. Well, the channel's name is, watch my magic whiteboard here, Zane Palmer. Zane Palmer. Now, if you just Google in or YouTube search Zane Palmer, you're going to find a million music videos, which I didn't realize either. But his place is called Palmer Armory. Also, Palmer Armory. Look this guy up. He's got a cannon. It's got a cannon and a tender. I believe he said there's 1,000 pieces or 10,000 pieces in this thing, and it's all handmade. You got to check it out. Leave him a comment. Tell him I sent you. Fantastic piece of work. Anyway, today I'm going to make a project on the lathe, and it's going to start off on the mill, and there's going to be two things that I'm going to skip over. I'm going to show you up close and personal as I'm doing it, but in case it doesn't, it's not very clear, I want to show you up here what I'm talking about. And those two items will be controlling a corner round cutter so you don't mess up your part and you end up with a feature that you want to see, and controlling a tapered bore to a specific depth without doing any trig. And it's not as hard as it sounds. So let's over the corner rounder. Corner round cutters are very simple. Holding out the markers is not. Okay, corner round cutter looks like this. Most of them. Radius, pilot, radius, shank diameter. Mine are 2-flute, mine are carbide. They come in a variety, 4-flute, high speed, whatever. If this, let's say this is an 1/8 inch cutter, 1/8 inch radius, that means that this radius right here, you expect it to be at least 125. So that means you have 125 from here to here, you have 125 from here to here. Usually and as a minimum. So if you have 250 and you measure the diameter of the tool, then you can come up with this X dimension right here. Now when you use a corner rounder, treat the corner rounding cutter as if it were an end mill this big. Don't pay any attention to this happy stuff going on out there, because all it's going to do is frustrate you and confuse you. Just consider it to be an end mill that big. Now I know my cutters are 5/16 diameter with an 1/8 on either side, and down here I have a resultant 0.60. So whenever I calculate where this cutter needs to be in relationship to the edge of the part, that's what I use right there. I just offset it 0.30 from the edge of the part, and the radius usually blends in quite nicely. Now naturally some of them have a couple of degrees worth of draft on the outside, possibly on the inside as well. You will get to know your cutters once you use them, and try them on a piece of scrap so that you can get a pretty good idea what you're looking at. I always cut with my corner rounders. It just gives me a better finish. Alright, let's talk about setting these things depth-wise. It's easy to set because you know the minor diameter of your cutter. You go half of the minor diameter, that's the offset. Depth-wise, you can count on, normally, quality cutter, at least the value of the radius for the depth. Now, one thing that's really frustrating is when you go too deep with a corner round cutter, and I know we've all done this. I've done it. And I'm going to erase some of this so you can see what's going on. Actually, I'm going to erase all of it. How's that? You go too deep with a corner round cutter on a part, and you have a nice rounded corner on your part, and you say, man, look at me, I'm really doing well. Then you got this step in your part because you went too deep with it. Well, you can file on that part until the cows come home, and the only thing you're going to end up with is a line on top of that radius that anybody that knows what they're looking at is going to know what you tried to do. So what you don't want to do is that. Setting the depth on a corner rounder is best done. Let's go back to the material that was theoretically just there a minute ago. When you bring your corner round tool down And I like to have my depth established, or at least know what my number is before I get to the finished pass. That way there's no guesswork and you don't end up with this. Take your tool, move your tool away from your part, and set your depth out here. That way, if you do happen to dial the table up a little too much, or you bring the quill down a little too far and you bark the part, well, look at this. You have all of this makeup space here to go and make it right. So when you set the depth on that corner rounder, stay away from contact in this area with the bottom of the cutter and work just on the edge. As the radius is formed on the part, you'll see that line coming around. I hope you can see that. And when that part of that radius is close to the edge of the cutter, then you're deep enough. Don't push your luck. If you want to push your luck and end up with a little bark mark, fine, do it. That way you know how far not to go. But set it away from the edge and you have all of this extra safety stock. Alright, that was way too long, but now you got the idea. The other feature is cutting a taper on a lathe to a specific depth without doing any trig. This is what we're going to do. We have the face of the part. It's going to be a 5-degree angle to a very specific depth. I'm not going to use any trig. I'm going to use the carriage movement to set the depth, and then I'm going to do everything with the compound, and I'm not going to worry about splitting hairs with the compound. I'm going to have hard numbers on the compound, hard numbers on the carriage, and I'm going to end up with the depth that I have. I do have a small wooden model on the bench in the shop. Let's take a look at how the model works. Sometimes visuals are better than this. And then we'll get on the lathe and actually make the part. Let's take a walk. Okay guys, I will narrate this when I get to the actual lathe work, but I think for sake of illustration, it may be a lot easier to visualize if I show you this way. The pink zone here is the depth of the feature. Okay, here's your part. This is the depth of your feature. This piece here is strictly there to illustrate the movement of the carriage against the depth of the feature. Once you move your carriage, and this big part here on the bottom is the carriage, here's your compound. This is your boring bar. Probably wouldn't hold up very well in stainless, but there it is. Register the boring bar against the face of the part. If you're worried about chipping it, then use a feeler gauge in between the part and the boring bar face so you don't nick your part or chip your boring tool. Let's assume that you now have an index mark on your compound and it shows you exactly where to stop, so everything is registered. The tool is bumped up against the part. You have a 0 registration on a drop indicator, or your digital is zeroed, and you know where your compound is zeroed. At this point, move the compound back off the part. Advance the carriage, if I get 3 hands here, advance the carriage to the depth of your cut. I just moved it, 750. Now when you return the compound to the 0 mark, let's jump that right there. Let's go to 0. Boom. When you return that compound to that 0 mark, that bore is now 750 linear. You didn't have to do any math to figure this out. All your math was taken care of with the carriage. Okay? One more time. Everything zeroed out. 0, 0, 0. Bump. Pull the tool off the work at least the depth of the cut, at least. Move the carriage, the depth of the required feature. Return the compound to the 0 index mark that you have on the side. The tool is now to the depth that you need. No math. I hope that makes it easy for you. There's just no simpler way to do that. Okay, today is another installment in the Canon project. I'm not going to tell you what I'm making until it's done. That was a real time on the clock, and that was a real temperature on the wall, and I can tell you I'm motivated to get this done. 7/8 diameter brass, 5C collet, 5C collet block. We're going to go into the mill first. Simple milling operation. Let's take a look. Okay guys, just because this is an easier way to film this, I am going to shoot some of this freehand. I'm using a 1-2-3 block in here, and I know this is a fairly precision 1-2-3 block, but when you see what I'm making, you're going to say precision is close enough, or close enough precision is good enough. So with the vise just mildly tight, push the 1-2-3 block against the side of the part that you're trying to locate while you're pushing against the bottom of the vise. And when you have contact, tighten up the vise. That is about as quick and dirty as it gets. I do this a lot. It works very well. I am going to do all my cuts left to right, front and rear, so I end up with a rib in the middle of this part. And then we're going to round it off. Let's put the end mill in there, indicate this thing true, and see what we get. For anyone that's ever attempted to indicate a part true to the spindle, you got to know that the first couple of rotations of the indicator are going to be the most frustrating. So what I always do is I keep my indicator above my part. And I'm holding this because I just can't get a bird's eye view of what I want you to see. Move the part somewhere in close proximity. And you can see that it's somewhere near the center of the swing this way. So if it's facing along the x-axis of your machine, line it up with the x-axis. Close enough, right? Same thing on the y. You spin it around, you can see it's just a little off. Looking at the body of the indicator true to the machine. Now it's not that far off, but it is off. So bring it closer now without making contact. Now in the back you can see the needle's about a 1/16 of an inch away. In the front the needle's about a 1/16 of an inch away. Left and right is pretty close as well. So now I'm going to move it to within the boundary of the part. Drop it down. And let's see what we got. Well, it's really hard to see with the glare. Let's turn that light off for you. Yeah, that works, huh? We're about 2 before. And if you're not quite sure what side of the zero you're on, look at the markings on your dial. This is a brown and sharp best test indicator. I am on the brown side. It says brown and sharp, so I am on the brown side, about 2 away. I come around to this side and I look at it, and I am on the sharp side, about 12 over, 11 over. So that's 13. Let's go to 6.5. 6.5. If it's 6.5 on the left and right, chances are it's pretty close in the front and rear as well. I am not going to get carried away with this for what this is. Try doing this with a camera in one hand and a milling machine in the other. 4 away, 4 away. We are very close. Four on the front. 4 on the back. 4 on the right, 4 on the left. Okay, dials, whatever. Digital readouts, if you got them, zero them out. This is an Accurite digital XY on this machine. It works really well. I love Accurite products. They do not sponsor this. But boy, if you're listening, feel free to send me something cool. Okay, here we go. I am using a 312 cutter. I'm looking for a 250 elevated rib, 200 tall. We're going to do it along the x-axis, and I will show you why in a second. Let's change the tools. Okay, straightforward milling job. That is a 150 raised element on the end of this piece of brass. That's 250 wide. Simple, straightforward job. You take half the cutter, half the final feature, and that is your offset. This was 281 in both directions to end up with a 250 wide notch. 250 wide rib. I'm going to put a corner rounder in there now, and I know a lot of people have seen these things. Maybe you have or haven't used them. But most of these corner round tools have a minor diameter in the front. And what you want to do is you want to measure that diameter right there, and then you treat that as the size of the cutter. Don't worry about the body of the cutter, don't worry about the radius. If you want to go tangent to the edge of your workpiece, I'm going to guess that that's probably around 0.60. So I'm going to put the camera down, confirm that, load this tool up, and then we'll go the 125, which is half of the rib, and then 0.30, which is going to be half of this tip right here. And we're going to make that top rib round. Let's do it. A really good rule of thumb when setting up a corner round, you can see that by the radius on this. Let's see if I can get that close without getting out of focus. Yeah, I'm thinking my camera's fine. I might be the one that needs glasses here. Okay, you can see that the outside part, and that's a really good shot right there, is a little above the tool. So what you want to do is run it back and forth across your tool with the bottom edge away from your tool. That way if you go too deep, you can always recover. If you're full bite and you go too deep, you're going to end up with a ridge and you're going to have to resurface the top. So I'm going to run this back and forth until that shiny edge is just about tangent with the outside, and then I'll take another picture for you. Hang in there. Now I think you can see how the section that's cut on the top is just about in line with the OD of the part. The reflection might be not doing me any favors here. Let's see if we can go this way. These tools usually have a degree or so worth of draft on the lead in and lead out of these radiuses. I am going to climb cut this to finish, and I'm going to treat this like an 0.60 end mill and just make my offsets accordingly, which ends up to be, I believe, 281? 218, excuse me, 218. So let's see if we can round this off. That feature is complete, and I have to make a correction. It's 156 in both directions, not the 218 that I said before. So now we have a 150 tall, 250 wide rounded feature on this. And now here's the reason that I put it in and did the work on the x-axis. I need to drill a hole in that. And without moving anything, I can just lay this block down and I'm still on center on the Y. So that's pretty easy. If you think just a little bit ahead in your project, you can save yourself some aggravation. And that is definitely a good trick. I'm going to visually pop a hole on what I believe is the center of that feature right there, by eye. And I'm going to line it up by putting a scale across the end of my vise and bumping this against the scale, locking the table down, and just flip the part over. Hole does not have to go all the way through. Okay, let's do that. Walk over to the lathe with it. Okay, there you go. Looks like a clevis for something, right? Now we're going to shift gears here. We're going to put a little bit smaller stock in the machine, and we're going to make the other part of this, so hang in. Okay guys, it is time to make the brass wire that I need. I do not have any here. This is a 5/16 diameter. I'm going to turn it down about maybe to 50 thou diameter for about 2 inches long. And if you've watched my other video on turning extended small diameters, you know exactly what I'm going to do. It's going to be one bite and we're just going to go for it. At the conclusion of each pass, I'm going to draw out on the compound, draw out on the cross slide ever so slightly so that the blend lines between each turned segment has some pilot material. If you just stop and back the tool off, chances are you may have a line in the part. If you leave a little conical feature, you can blend from one diameter to the next of the same diameter cuts. So let's check it out and see if the camera stays in focus for the whole thing. That would be awesome. Let's get her done. Oh, there's a reference. Now I'm just going to plunge straight in with this TPG tool and part this off. There you go. By doing that small flare in between passes, it eliminates any hard line that you're going to have, and you end up with a really nice product, nice and straight. The key is one pass. Well, multiple passes, but one bite, one depth, and go. There you go. Let's bend it up into something cool. Oh, another reference. Okay guys, we are going to knock the center of this thing out. And we're going to knock it out on a 5-degree taper. Now I want to control this 750 deep from this edge right here down at 5 degrees. Now there's been some questions from some of you guys about how to do that. So I'm going to take and see if I can freewheel this and show you exactly how I'm doing it. My dial is set on 0. My cross slide is not in the picture right now, but the compound dial is set on 0. And I have a witness Sharpie mark on the side of the block letting me know where that 0 is. Take the tool, run the tool up against the face of the part, or find it however you need to. Zero. Get off the part, clear the part with the tool. Take the entire carriage hand wheel, 750. And zero it again. I like working to a 0, not to a number. It's just easier to remember what the number was. Okay? Alright, so we are good to go on the depth of that. I'm going to take a hole, I'm going to pop a hole in it about 720 deep so I can finish it with the boring bar. Then I'll reset and I'll show you the cut. Okay, I have a half-inch hole in that. 720 deep from the recessed surface, so that's 870 from the contact on the upper lobes. I am going to back my compound off at least 1 inch from the 0. Now I know there's at least one person out there that knows what this is. Emma, I'm talking to you. Okay, when the compound is returned to 0 and the travel dial or indicators or digital readout is reading 0, the tip of that boring bar is going to be 750 below the recessed surface on this part. Bearing that in mind, do not go past the 0 on the compound for any cut that you make, and watch your digital or your digital readout or your drop indicators so that that doesn't go beyond the 0 as well. And the tapered feature will end up at the desired depth set by the carriage movement. Let's take a look. Cross slide, I am going to face off the bottom. Going to move the carriage out. think you probably figured out what this is by now. Now the next cut will be done full cut, full depth. And this particular philosophy is why the rounds were done on this first. And the same philosophy used to make that long skinny pin. You use the existing material as the support material for what you're doing. We're going to get a visual on this and then we're just going to go for it. Alright, I think that'll do. Let's see what happens. All the way down. Alright, anybody care to guess what that is? I think Emma knows what it is. Alright. Get off, shine it up. Slip the machine out of gear here for a second. Put the lobes top and bottom. Check the alignment of the parting tool. Dragging this up and down the face, looking for a snip or a ring on the edge of the parting tool. There we go, just a little bit. Now I know that the inside feature is 750 deep. So let's make the outside 800. This is where you zero out your digital, zero out your travel dials, your indicators, whatever. Let's move into 800. I am not going to cut this all the way off at the moment. And there'll be a reason for that. Now that I know what the profile looks like, everything is zeroed out. I'm going to put a couple of scratch marks in the OD of this, just for cosmetics. I'm going to use a threading tool to do it. This is strictly ornamental. It means nothing. I'm doing it by eye. little double 45 from before. Which is really high for some reason. I'm going to deburr the bottom. Tool back in, everything back to zero. Watch your fingers. Off it comes. Just a little bit hot. Okay. Let's go clean it up, put a handle on it. Okay, there it is. This is the bucket that's going to hang on the front of the cannon. And you can see why I did the sides while they were solid. The impact from that radius cutter would have just blown these all to pieces, so there you go. I am going to bend this up, and I can't do both on camera, so I will bend it into a hoop and I will put it through those ears and bend it and show you the final product here momentarily. Okay, there you go. Done. The entire thing turned down from a 7/8 diameter chunk of 360 grade free machining brass. There's one more piece of the cannon. Thanks for watching. Okay guys, well I hope you saw the application of the carriage movement, the compound being set to a 0 before everything is done, how the corner round was applied. It all worked out very well, and the reason the corner round was done before the feature was the wall thickness on that little bucket would have probably distorted and slapped away or pulled into the cutter because I like the climb cut. So plan your work, think ahead, think smart. Hope you got something out of everything that you saw. Thank you very much for stopping by. Joel Pye, Advanced Innovations, Austin, Texas. I'm out.